Hi, welcome to uh, the exercise to demonstrate the deep Q learning for the CartPole game using Python and Keras, and of course under the OpenAI gym. Before we jump into the code, let's give a brief intro. The CartPole balancing problem, it is a classic inverted pendulum problem. So basically we in this exercise we simulated our mini world as a graph of connected states. We should consider the current state and whatever action we need to be doing. The cart pull problem deals with a cart moving along the horizontal axis and a pole anchored on the cart. Every step we can view its position, velocity, angle, and angular velocity. Cart has only two possible actions in each step. These are move to the left or move to the right so that it can be balanced. In this game, uh, the we get a reward so long as the pole is upwards and the cart is within the bound. An episode of this game is said to be done when the pole falls beyond a certain angle or a cart is pushing too far off the left or right. In the Q learning method, we make sure that we should try to maximize our reward. We evaluate a Q value for each state action pair. The Q value stands for the likelihood of an action given the current state. Let's go to the CartPole coding exercise. So we first import the modules that we are going to do. We're going to use, of course, the gym, OpenAI gym, the random number because of it's a game, so it is related to some randomness. So that's why we have random number, operating system, OS, NumPy collections, and also Keras tools. So let's run it. So once we run it, it's loaded in our collab environment. Now, what we did here is for the cart poll exercise, we have prepared a class, Python class agent, which is basically a deep Q learning agent. So the purpose of encapsulating everything in the class is to provide a framework for such an agent so that outside of this class we can manually manipulate the inputs and we can study the outputs. So let's go. Let's go to see what our class contains. First of all, the class has an initialization method where we define the hyperparameters. Mostly, there are two types of hyperparameters we are talking about. Environmental hyperparameter related to the CartPole environment in the OpenAI gym and the training hyperparameter, which is related to the Keras. And of course, we define the storage files, and then we have defined other methods that builds the model. And you can see this is a typical multi-layer neural network model. It's a sequential model with with three layers, and we use the Adam optimizer. These are pretty straightforward and standard. And then we basically store the weights in the we back up the weight in the in a file. This is the file name. here is the file name. So then we this method save model is basically saves the model at each whenever we want. Then act is the most important part because it initiates the action. As we said that it in the Q learning process, we do some action and then we get reward. We remember the previous state. So state and action are the two important ingredients along with the rewards, which is the performance of the learning. So these three are the main ingredients of the deep Q learning. So then we have the, I mean, remembering the state variables. We have defined a remember function. Then of course we replay the game at each iteration or each episode. So this is done here. So let's let's load the class. Okay, the class is loaded. Then we are doing it in a in the Google Colab environment. It's not a standard Linux or Windows operating system. So, in order to run the graphics of the game, we have to do some little tricks. We have to install some utilities. So that's what we did here. These we set up a virtual display, and let's do that installation first. So we are installing those tools so that we can run the game, we can play the game, and we can display the necessary graphics. So let's start the display now. Okay, that's minor environmental setups we needed to do. Then comes how do we run the game? So basically now this is the driver code, which will driver code or driver macro written in Python that will basically inject all the parameters inside the game, inside the model, and it will train the model. It will access the reward. It will pass over the different states and try to maximize the rewards. So let's see how we achieve this. So we pass like sample batch size as 32, and we we use 10,000 episodes. We have to really, by episode, we mean we have to really check after how many episodes it starts learning the things so that it can um, maximize the rewards. In the document, I have shown different snapshots of the episodes. Let's go move forward. Now we are using CartPole dash V1 environment in the OpenAI gem. So that's a gem.make CartPole VI. So that defines our environment. So first we initialize the state. So we reset the environment. So that's basically initialized state. And then we have a screen corresponding to that initialization. Then we go to we basically show the plot of the screen. Uh, then we grab the environment parameters like the state size, action size, and then we instantiate the Q learning agent that we defined before here. Here. So we instantiate this agent. Where is that? Here. So we instantiate the agent and then we start training the agent to play the game and just saying the agent, go play the game with these inputs and try to maximize your score. So that's basically is done here in this for loop. So we reset the environment and then we define the state. Then the done is whenever uh, as we defined before, it's the end of an episode. So first we define done as false, and then we start a while loop. While not done, we start the action. So we start the state manipulation, and then we go through these steps, um, and then we store the next state, reward, and action, and finally, when this is done, means one episode is done, we go to the next episode. That's the concept. And when we go to the next episode, we plot the screen. Basically, the environment, we render the environment and plot that onto the screen and display the result. So, and we also have printout on the console that will show um, how the system, how our agent is learning and getting rewarded. So let's run it as an example. So we initiated this. Let's see what happens. So you can see that it's slow because it's not perfect. It's very slow. So we started the cart pole game, and you can see this cart pole is balancing. So the balancing act is working here. I mean, in order to get a faster response, of course, we need a more efficient computing resource than Google Colab. But the baseline of this function, you can see it's working. So while you can enjoy looking at the game, let's say some concluding remarks about the deep K learning that we have learned um, in this exercise. So what we have learned here is the essence of the deep Q learning in this game. This game is driven by a reinforcement task where it trains the agent that interacts with the environment. The agent arrives at different scenarios known as states by performing actions. That's what we did in the act function. The action leads to rewards, which could be, which could be high or low. The agent has only one purpose here, to maximize the total reward across the episodes. This episode is anything and everything that happens between the first state and the last or terminal state within the environment. We reinforce the agent to learn to perform the best actions by uh, training, by experience, by gathering experience through the training. So this is the strategy or policy underlying the deep Q learning. Hope you enjoyed this demonstration. Thank you so much.